I hope you're all doing good. Today I'm Mr. Ish. Thank you for joining me for this video where we are examining this reason or the reasons behind why coding an algorithm, normally a simple algorithm, can be difficult and or tedious. Why would that be the case? If you are using a simple example, let's use a guessing game from 1 to 10. It doesn't look like a difficult algorithm, but coding it can be quite tedious. And why would that be the case? Let's look at it. If you're looking here at a number 1 to 10, I come to the computer and the computer asks me to pick a number, and I pick a certain number and I hold it in my head. And now the computer will ask me questions to determine what number it is that I thought of. How can the computer start the initial procedure as to determining what it is I'm thinking about? It can probably do some sort of differentiation procedure where it can determine or start separating or narrowing down its focus. And a good procedure it could do is the number I'm thinking about even or odd? Now if the answer is yes, there's a bunch of numbers that it could be, but if the answer is no and it's an odd number, you know it can be a bunch of other numbers. If it's yes, you know it's a 2, 4, 6, 8 or 10. If it's a no, it's a 1, 3, 5, 7 and 9. So the computer has asked me this question and I gave it either a yes or no answer and has these. Now it can ask me some more questions. Now is the number I'm thinking about, let's just say, larger than 7? If I answer yes to this question, remember the computer can ask me clues, and of course I will answer those. If it's larger than 7, we know it could be 8 or it could be 10. But if the answer is no, it's not larger than 7, we know it could be 2, 4 and 6. Coming down over here, the computer may ask, based on the outcome over here, that it's looking for an odd number because I answered no initially. It can ask me this type of question: is the number larger than 6? If I answer yes over here, we know we're looking here at either a 7 or 9. But if I'm answering a no over here, the computer is thinking about either 1, 3 or 5. But we're still not done. All of this has to be coded as you know it normally would be. Here we're looking at the reason why algorithms can become tedious. They can be tedious because you can have these large tree-like structures develop with a lot of decisions that are involved. When we're coming over here, the next thing the computer can ask is a number larger than 9. If the answer is yes, we know it's a 10. If the answer is no, we know it's an 8. So that part has come to an end. But when you're looking over here, it's not as easy because there's some decisions that have to be made. We have 2, 4 and 6. Is the number larger than, let's say, 5? If the answer is yes, well, we're looking at a 6. But if the answer is no, it still can be 2 and a 4. So it's not ended. Coming over here, the computer can ask us this: is a number larger than 8? If the answer is yes, we know it's a 9. But if the answer is no, we know the number is 7. So that part has come to a complete. When we're looking over here, we know the computer may ask us this: is a number, let's say, larger than 4? If the answer is yes, we know it's a 5. But if the answer is no, it's still a 1 and a 3. So these are not at completion yet. Coming here, 2 and a 4, we have to do a distinction here. The computer may ask, is a number, let's say, larger than 3? If the answer is yes, well, now we know it's a 4. If the answer is no, we know the answer is a 2. So that has come to an end. And then coming down here, 1 to 3, the computer may ask, of course, this: is a number larger than 2? If the answer is yes, we have a 3. If the answer is no, well, we know we have a 1. So everything has come to a completion. We've gotten our 1 over here. We have our 2 figured out. We got the 3. All the loops are giving rise to all the possible questions which the computer should be able to come to, because you could be literally guessing any number from 1 to 10. 5, 6, 7, 8, 9, 10. A simple algorithm such as this is quite tedious and or complex for 2 reasons. Reason number 1, you have a lot of decisions involved, or a lot of hierarchy of decisions. You have 4 hierarchies of decisions. Here's your 1 right over here. And then you have these set of decisions over here, and we'll call this number 2. And then you have these set of decisions, we'll call this our 3rd hierarchy. And then you have these set of decisions, which is our 4th hierarchy of decisions. You have 4 decisions here. The reason number 2 why coding algorithms is difficult, you have to account for all possibilities. All the decisions and or loops or the trees should lead to each of the possible outcomes, and they all do. You can see 1 through 10 are all represented by means of a logical framework, and sometimes coding that framework can be difficult. But here we've addressed in this video only the reasons why coding algorithms, even simple algorithms, is complex, and I've given you 2 reasons for that. And that was all I wanted to talk about in this particular video. Thank you for watching.